Alright, so here's a general polynomial power function here, and we're going to determine if this is an even or an odd function. So, here, in case you probably want to read it, it's f of x is equal to x to the 2n plus p times x to the 2n minus 2 plus mx to the 2n minus 4 plus dot dot dot, just random extra terms in there that follow the same pattern. You can see the pattern, which I'll tell you about it in a bit, and then plus k. And this is with the assumption that m, p, and k are real, and n is a natural number. So what's the pattern here first off? Well, these all have two n's. X is raised to some power of 2n, and it's being subtracted off by like 2, 4, and then probably next you'll guess that it's 6, 8, 10, 12, and you're right. It's even. So we want to see if it's even or odd. And to go through that, we're going to do f of minus x. So let's put in minus x everywhere we see an x here. It's going to be minus x to the 2n plus p times minus x to the 2n minus 2 plus m times x to the 2n minus 4 plus dot 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 plus k. And let's go ahead and simplify this. Well, if I have a negative number and 2n, well, what does 2n represent? 2 is an even number, and n can be in any number, even or odd. And if I multiply any number by 2, it's going to be even. And if I take a negative number to an even power, it's going to end in positive. So I'm going to get x to the 2n, because those two are equal. And then for plus, I have p. Well, I have 2n, which is even, and I'm subtracting it by 2, an even number. So in turn, that's an even power, and that's just going to be a positive number, x to the 2n minus 2. And then it's going to be plus, same logic here, even number minus an even number is still an even number, and therefore, oh, mistake made there. I meant to put m times minus x to the 2n minus 4 plus k. And so that's just going to be a positive number still. M times x to the 2n minus 4 plus dot dot dot, extra terms, and then plus k. The k is unaffected because there is no x term there. And, well, if we look at this function, if we look at this result, if we look at that, we see it's exactly the same as our original. And so f of x is even. So if we have a power function with any, to be general, I should have said a. I should have put an a at the beginning of that. So pretend there's, in fact, let me change that. That's ax. So if I have some numbers, if I have a power function that looks like that, just any powers of any even powers of x, so like 4x to the 6th minus 2x cubed, 2x to the 4th, plus 7x squared plus 6. This is an even function. In the next video, we're going to do odd powers.